All right, welcome back to the last part of this week 3 lesson in MSE 2114. So this last part is just for our practice problems, and so this practice problem section tends to be problems that'll just help you practice things like writing functions, maybe doing loops, maybe reinforcing plotting, things that we've seen, but we want to make sure that we have practice doing. And so we'll go ahead and look at a couple of different things again. So to remind you of how to use if, else statements and writing your own functions. We've got here a function I've defined just called myfunc. And you can see here that it takes 3 variables in this case. And if variable 1 is equal to 0, it just returns 0. Else it will return variable 3 divided by variable 1. Okay, so that's my first if statement. So this will happen, and then I've got another if statement, and these are not nested. Notice they're the same indenting. And so this is just the second command that it'll go through. So it'll go through this one, and it will go through this one. So the next thing it's going to do is if this ratio, and so up here, if I don't, if the variable 1 is not 0, then it will calculate ratio, and now it's available for this. So if the ratio is less than 0, I'm just going to return 50, and then else if the ratio is equal to 0, I'm going to return 1. Else if the ratio is equal to 0.5, I'm going to return 60. And if none of those conditions are met, then I'm just going to return the ratio. Okay? And none of these values mean anything. This is just completely made up. But just to show you how you can use these statements. Now remember, with the else if statement, this ends as soon as one of these statements is true. It doesn't continue through. So if I've got, if the ratio is less than 0, then that's it. It returns 50 and then it ends. Okay. If that's not true, then it'll continue on. Then it'll check and see if it's 0. Then it'll check and see if it's 0.5. And then finally, if none of those work, then it just returns the ratio. Okay. But the else if is nice, is that it stops as soon as it hits one that is true. All right. So that's my function. I'll go ahead and run that. And then we're going to go ahead and plot it. So I just want to show you a way to plot functions. Okay. So what you're going to need when you plot a function is you're going to need in your plot command, right? You got to pass it x values and you got to pass it y values. So let's first take a look at this Numpy Lin Space. There's a lot of ways of getting an array of values. But the Numpy Lin Space is actually quite nice in that it tells it, in this case, to go from -1 to 4, so min, max, and you want 21 points. Okay, so in the NumPy case, this min to max, this max here is inclusive, so we do get the 4 here. Okay. Nothing funny with the way indexes work inside of data frames, for example. And then we also get 21 points. So rather than telling it to make an array from, -1 to 4 and use a step size of something, and then that step size you have to figure out yourself whether it's going to be the right step size to get to 4. This one does it for you, which is great. So I just want 21 points and I want to go from -1 to 4, and it figures it out for you. So all right, so that's a nice command. The next thing we can do is use a list comprehension. This is just a nice simple way. Go ahead and take a look at this piece. So what does this one say? So remember, the list comprehensions we do by putting the list brackets around it. Those are critical. Then we can say, okay, this is my output. So I want you to output this, So it's going to call my function, and it wants an x, and I'm giving it the variable 2 and 3. So those are fixed. It's just looking for a bunch of x values to put in here. Okay, so that's going to be my output. And then you tell it for the variable that you want here, x. So do this for x in, and then you give it a list or an array, in this case, of x values. And so my x values, I'm going to use this Numpy Lin Space to get. So that's all of these numbers here. Okay. So you could do this, let's say this was, just show you manual, so it's not quite as hidden. So let's say I got 0, 1, 2, 3. Okay, so it just simply takes 0, 1, 2, 3, that's my x, and puts it into my function and outputs my values here. Okay, notice one of my values, let's see what we got. So ratio, variable 3 divided by variable 1. So 3 divided by variable 1. So when 1.5 is divided by 3, that value is a half. And notice right here I have, if the ratio is 1/2, return 60. So there's my 60. Okay, so that's as easy as it is, except instead of putting this in manually, we can now just put in this whole Numpy Lin Space. All right, so then for plotting, I've got my x values, and then I'm going to use my list comprehension to generate all of my y values, because notice it outputs it as a list. And then I'm going to make those red points again. And there it is. So you can see it outputs 50, below 0, it's 0, it's 0. And then it's outputting the ratio until it gets to this one case, and it jumps up and gives me a 60, and then starts outputting the ratio again. Okay, so that's how we can, again, plot, use a list comprehension, the Numpy Lin Space, and using the else and else if. So one of the things you can start seeing, especially in this lesson, I know that we've got a lot in it. One of the things that's really helpful is if you start creating for yourself a cheat sheet of commands. So, make a Python file and put in it things that you want to remember and you might need later, like this Numpy Lin Space. That's a really helpful function. Maybe put in it an example of a list comprehension, okay, and comment in your cheat sheet what it's actually doing, so that you don't have to relearn every time. You've got it all written there for yourself for use later. Knowing how to do a simple plot when you've got some kind of a function defined. It's nice to have that. So start making yourself a cheat sheet so you don't have to scroll through all the lessons and try and figure out where those commands were that you saw one time. All right. Another case we just want to look at is generating some random points. So here I've got some, I'm going to generate some x coordinates, and I'm going to generate some y coordinates, and I'm going to go ahead and I'm going to take the magnitude of these. So these are the x and y values for, say, a vector. When we pair them up, I'm going to take the magnitude of that vector. So that's just the square root, right, of the x value squared plus the y value squared. Okay. Now in this particular case, I've got this minus 0.5 one here. And so what I'm doing here is I'm shifting all of my values here to a new coordinate at minus 0.5, minus 0.5, and I'm taking the magnitude relative to that new origin. Okay. I'm sort of playing around with that here because, for example, if I wanted to know, points that lie in a circle with some kind of a center, 0.5, 0.5, then I want to shift all of my, when I do my testing, I want to calculate that magnitude relative to that new center. So best thing for this is probably to sit down with a piece of paper and draw out your circle with a center at 0.5, 0.5. Put some points in it or around it, and then connect them and figure out what you need to do to figure out magnitude-wise whether they lie in that circle. So sketch it out, because this is not going to be quite right for what you need to do. I'm just kind of showing you an example of finding a magnitude, okay, from a set of points. These I just made up. And then you can see what's output. Now the reason why I didn't do this as a straight list but used the NumPy array is if this was a list like this command here wouldn't be as easy. I'd have to use a loop to loop through the list to find this. But by making it an array, NumPy array, and using NumPy commands, NumPy automatically knows that if it's an array, you want to do your calculations or your math on the entire array. And so it makes things very easy, like, you know, x coordinate minus 0.5. That means subtract 0.5 from every value in here, and then raise it and square it, every value in here, and then add that to the same thing done to the y coordinates. And so it makes the math very simple, because now we're doing it for the entire array list, and I don't need any looping. So that's the advantage of using an array, NumPy array, versus leaving it as a list. All right, so that's the trick there to make your math much easier for that problem. Then we can go ahead and plot this. I'm using a little bit different format here, and that's because I want to below, I want to start giving a different color to some of these points. And so the more general format for doing the plots, instead of just saying plot and then using plot, is this format. This is just more general, and it allows us to do more things later. And so it might help to get used to this kind of a format. But we're going to use plot.subplots. This allows us to control each plot on top of this figure that we want. And so when we do this, we have a figure, and then we have what's called an axis. Those are the two outputs to this subplot command, and we can now affect both of these separately. So the actual plotting that goes on top of this whole thing, which is called the figure, is these axes, it's called. So I can call the axis piece, and that's where I'll actually do my plotting and make it red. Okay. And I set an aspect, and I'm going to do a show. All right, so far this is the same as we did before. We have this weird extra step, and instead of doing plot.plt.plot, I'm now doing a x.plot. I can call these variables anything I want, I just didn't have to use them here to be consistent. This is just generally what people use as a convention. All right, so here I didn't need to do this, but below I'm going to change and use different colors for my different plots. All right, so I've got that magnitude list. I could do my testing again. I could take that magnitude list and say, go ahead and select all magnitudes that are less than 0.7. Okay, so that's 1 point. This is the only one that's less than 0.7. So I'm going to take that 1 point and replot it and give it a different color. Okay, so there's my test. So these are some now x and y values that passed the test. And now down here I'm going to do my original plot like I just did. X coordinate, y coordinate, they're red. It just reproduces this above plot. And then I'm going to do another plot on the axes, and that one I'm going to just plot the x and y values that pass this test. In this particular case it's just 1 point, but it could be 100 points. And I'm going to plot those as black. Okay. So since I'm plotting this one after this one, it takes the red point that was here, and it's still there, it's just underneath, and it plots this on top of it, so I've basically turned that point black. And so this now is showing us all of the values that are less than 0.7 in magnitude. All right, and all right, that's about it. And I got plot.show. You can play around with this set aspect. I've got it set to equal, so I should essentially have equal lengths on this axis versus this axis in terms of the tick marks. But you can set this to different kinds of aspects or remove it altogether. A good way to do that when you're testing things is just use that pound sign. Oops, I didn't run this. I forgot to run my test. Now run this. Okay. So you can see the effect of the set aspect. Set aspect is nice. Let's say, for example, if your problem is talking about circles, which yours is, if you don't have the set aspect on, then your circle, when you plot it, it's not going to look like a circle. It's going to look like an ellipse. But when you set the aspect to equal, then when you actually do your plot, your circle will look like a circle. So that's why I included it here. It'll help you with your particular problem. And you can look up set aspect and you'll see all the other choices that are available here, as well as numbers you can put in to set it however you wish. All right. Okay. Later, so it doesn't look like this subplot has done a whole lot for us, but later what we're going to use this for is we'll be able to tell it here how many plots, so I can actually do a separate plot next to this if I want, or maybe even below it, how many plots I want. And then if I have more than one, then I'll have more than one axis here, so I might have AX1, AX2, and then I can address each of those independently, so I can make a figure like a plot here, and then a plot there, and a plot here. And then overall, the whole thing is called a figure. And then the figure, we can control now the size of the overall figure. And so a lot of things we'll be able to do with that. For this problem, we actually needed to do this so that I could use this set aspect command. That one's not available in the shortcut way that we plotted up here. I can't do a plot.set aspect. It won't work. So, all right, I think that is it. And let me know if you have any questions, and I'll talk to you later.